Okay, so we're studying square root and cube root functions, and we're going to be graphing these. And basically there's two shapes you're going to have to memorize. One of them kind of looks like this, and the other one kind of looks like this. And we're going to be moving these shapes around graph paper and things like that, but it's going to be really important to recognize which is the square root, which is the cube root. And so for the first one we're going to be studying is the square root function. And I already have a table of values over here that I want us to find, but we're going to be looking at y equals the square root of x. Now, to figure out who y is when x is 0, we plug 0 into our square root function. The square root of 0 is 0, and so I put a point at the origin. Then we have 1, plug in 1, the square root of 1 is 1, and so we put a point at 1, 1. Plug in 4, the square root of 4 is 2, and so we put a point at 4, 2. And then finally with 9, plug in 9, the square root of 9 is 3, and so we put a point, 5, 6, 7, 8, 9, 3. Okay? And so we're going to connect these points with a nice smooth curve. We're not going to draw straight lines, but just kind of a nice curve. Oops, I kind of missed that one right there. I'm going to come back and try and get that just a little bit nicer. Okay? And that's pretty much basically what your square root function looks like. It's this curve right here. Okay? And when we're adding and subtracting things to our square root, this curve here will get shifted around the graph. Okay? Now you're going to hear me refer to this point right here. We're going to call that the anchor point. That's not the technical name for it. I don't really know the technical name off the top of my head, but we're going to call that the anchor point. And this is what you want to memorize. You want to memorize that it starts at 0, 0. Then to get to the next point, you go over 1, up 1. To get to the third point, you go over 4, up 2. And then over 9, up 3. That's going to be really, really important to remember. Okay? Over 1, up 1 from your anchor point. Then over 4, up 2. And then over 9 and up 3. Very, very important. Now the other thing we have to talk about is the domain and range. Okay? And if you think back to last semester, we were talking about domain as the set of all x values for which this function is defined. And basically what that means is look at your graph here, okay, and tell me how far left are we going to how far right are we going. So I'm looking, and I see the leftmost point that we have is 0, okay. It goes as far left as 0, and it keeps on going to the right for forever and a day. And so what we'll say is that x is between and including 0, but then it goes up to infinity. Now you might see this written a little differently. Okay, you might see it written as x greater than or equal to 0. These two mean the same exact thing. Okay, x is bigger than or equal to 0. Hey, x is bigger than or equal to 0. It's just less than infinity, and again, it never gets to infinity. You might also see it written in interval notation, which in that case goes like this: bracket 0, comma, infinity, parentheses. So the other piece we have to talk about is the range. And remember, the range is the set of all y values. Basically, it's asking how far down does this graph go and how far up. Well, you can see that the lowest point on our square root function is 0. Okay? So range also starts at 0, and the square root continues going up for forever. It never, ever stops going off. I know that it may look like it levels off, but it doesn't. It'll continue going up for forever and a day. And so that goes up to infinity. One thing to notice is that it can equal 0. It'll never equal infinity in both the domain and range. Okay, so you could also write the range, y greater than or equal to 0, and same thing, 0 to infinity. All right, now we're going to start shifting this graph around. It's going to look exactly the same, and it's going to be important to remember. The anchor point starts at 0, 0. Then you go over 1, up 1, over 4, up 2, over 9, up 3. That's going to be so important to remember. Now, there's two things we need to know for vertical translations. And by vertical translations, I mean shifting up and down. Okay? When you are adding on the outside, that is a shift up. When you are subtracting on the outside, that is a shift down. So right here we have the square root of x minus 3. And when I say on the outside, this is what I'm talking about. This minus 3 is not in the square root. It's on the outside of the square root. This square root ends right here, and only x is on the inside. The minus 3 is on the outside. So what that tells me is since we are subtracting 3, this is going to be a downshift. The anchor point, which would start at 0, 0, okay, gets shifted down 1, 2, 3 units. And so we start right there at 0, negative 3. Then remember what I said. It's going to be important to remember from the anchor point, you go over 1, up 1. Then you go over 4, 1, 2, 3, 4, up 2, 1, 2. Put another point. From the anchor point, go over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3. Okay, and very, very quickly we have created our square root function. Now you'll notice that if I want to know what is the domain and what is the range, well, for domain, that doesn't change, okay? Domain, again, talks about from left to right, and that didn't change. We still start at 0. The leftmost point is 0, so the domain is still 0 less than or equal to x, less than infinity. It's the range that changed with a vertical translation. The lowest point is no longer 0, okay? The lowest point is now negative 3. So it starts at negative 3, and it goes all the way up to infinity. Now for this we have f of x equals x to the 1/2 plus 2. Now don't be fooled by this 1/2 power. The exponent is 1/2. Remember, that is the same thing as the square root of x plus 2. Okay? Square root of x is the 1/2 power. Now I see what we're doing here is we're adding on the outside. And so that's a vertical shift up in this case. Well, before we start graphing, let's talk about domain and range because it's going to be important to be able to state the domain and the range without looking at a graph. And remember, if you're just moving up, okay, the domain is unchanged. So for the domain, we are still 0 less than or equal to x, less than infinity. For the range, okay, this is what changes. The bottom is no longer going to be at the anchor point 0, 0. That anchor point gets shifted up 2 units. So this is going to start at 2 and go all the way up to infinity. So again, when we plot here, typically the anchor point starts at 0, 0, but because of this plus 2, that gets shifted up 2 units. And then we draw our other points based on that. Over 1, up 1, over 4, up 2, and over 9, 5, 6, 7, 8, 9, up 1, 2, 3. Now I included this last one down here because I don't want you to be fooled. I see it's a square root function and I have this number going on the outside. Now I know it says plus right here, but that plus deals with that square root. This minus 1 is exactly like subtracting 1 on the outside because this function can be written as the square root of x minus 1. These two are the same exact thing. So think about your domain and range. Remember, with a vertical shift, a vertical translation, the domain remains unchanged. You're not moving left or right. So that stays the same. It's the range that's going to change. And since we're shifting down 1 unit, our lowest point now becomes negative 1. And then our highest, we go on to infinity. So again, anchor point starts at negative 1. We went down there, 0, negative 1. And then it's, hey, over 1, up 1, over 4, up 2, and then over 9, 5, 6, 7, 8, 9, up 1, 2, 3. And there we go. And so that's the square root. You have to remember what this looks like. you have to remember that the parent function, and when I say parent function, all I'm talking about is this square root of x. You have to be able to remember that the domain is 0 to infinity and the range is 0 to infinity. Because then shifting things around will become much easier. And figuring out what your domain and range are based on what you're adding and subtracting is really easy as well. Now let's talk some horizontal translations. We've done vertical translations. Now let's talk horizontal. And this is the one where it gets a little opposite. If you think back to last semester and some parabolas we were dealing with, when we added on the inside, that was a shift in the opposite direction you would think. Instead of going right, this one goes left. And then for subtracting on the inside, that is your shift right. Now, here's where on the inside is what I mean by that. See how the minus 3 is underneath this square root? That means you're subtracting 3 on the inside. And so what this tells me right here is we're going to shift that square root 3 units to the right in this case. Now, if it's a shift to the right, that's going to affect the domain, okay? And so the domain is the anchor point won't be starting at 0. Now the anchor point is going to move 3 units to the right. And so the leftmost point now is going to be at positive 3. So the domain goes from 3 all the way up to infinity. But if it's just a horizontal shift, the range remains unchanged. We didn't move up or down, so the lowest point is still 0, and the highest point still infinity. All right, so we got our anchor point here at 3, 0, and then it's still the same. Go over 1, up 1. Go over 4, 1, 2, 3, 4, up 1, 2. And I don't think I'm going to have enough room to put the 9th or the 9 over 9 up 3. 1, 2, 3, 4, 7, 8. No, I don't have enough room. So we're just going to go ahead and connect these 2 points there. And we're done. Now over here, we have f of x is, you'll see that I have the 1/2 power again. Don't be fooled, that's still the square root function, okay? And we're adding 1 on the inside. So this is a horizontal shift to the left. The anchor point, which would start at 0, 0, gets shifted to the left 1 unit. Then we're going over 1, up 1, over 4, up 2, and then over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And I draw my square root function. Now we haven't done domain and range yet, but I know that the domain is what's going to change. Okay, since this got shifted left 1 unit, the leftmost point will be -1, and it goes on to infinity. The range, well, we're not shifting up or down, and so that remains unchanged. And so for our final one here, I've just kind of written it a little bit differently, but you'll notice that we have 3 plus x. That's okay that that 3 is in front. It's a positive 3. This could be rewritten as the square root of x plus 3. And so this is another horizontal shift to the left 3 units. This graph is going to be identical. Excuse me, no it's not. I thought that was going to be a plus 3 over there. I forgot. This one is going to be a leftward shift 3 units. And so the anchor point, which would have started at 0, 0, 1, 2, 3, it's now at -3, 0. And then the other points are found using the same method. Over 1, up 1, over 4, up 2, and then over 9, 5, 6, 7, 8, 9, up 1, 2, 3. And then we're going to connect our points. So the domain, remember domain is left to right. Because it's a shift to the left, goes from -3 all the way up to infinity. And the range, because it's not a vertical shift, remains unchanged. 0, less than or equal to y, less than infinity. So that's the end of part 1, which is the square root functions. Now go find part 2, which is going to be the cube root.